discuss operations with rational expressions. Now, rational expressions maintain some similar properties and operations as with any other traditional fraction. So we can simplify rational expressions like we would a regular fraction. We can also add, subtract, multiply, and divide rational expressions. So let's start with simplifying. Think about these 5 fractions here and see if you can identify which ones would simplify. So now, if you've identified the ones that will, 4 over 22 can reduce, 21 over 48 can reduce, and 20 over 32 can reduce. All of these can simplify, so we want to think about how do we simplify a fraction. I'm looking to see if there's a common factor in the numerator and denominator. So we want to find that common factor in both the numerator and denominator to reduce the fraction. Quickly, if we go through these, the fraction 4 over 22 would reduce to 2 over 11. 21 over 48 would reduce to 7 over 16. And 20 over 32 would reduce to 5 over 8. So what we're doing is breaking this down into common factors. As I look at 20 over 32, let's just start there on that last one. That could have a common factor of 2, but the greatest common factor is 4. We're writing that 20 as 4 times 5 and the 32 as 4 times 8. So there's a common factor of 4, and 4 divided by 4 is just 1, which leaves me with 5 over 8. So it reduces down to 5/8. We're going to use this same process for a rational expression, but we first need to put it in factored form. Now, if you need to practice factoring a little bit more, there are practice pages of just factoring and a video explaining going back through some of those prerequisite skills. So I have an expression x squared minus 6x plus 5 over x squared minus 2x plus 1. To put that in factored form, we would factor the numerator to x minus 5 times x minus 1. And then the denominator factors into x minus 1 times x minus 1. So there is a common factor of x minus 1. The common factor would reduce to divide out. It's going to divide the same thing by itself, which is just equivalent to 1. So we end up with x minus 5 over x minus 1. Our second one here is 2x squared minus 12x minus 32 over x squared minus 14x plus 48. We still want to put this in factored form, and one of the things I notice in the numerator is that numerator has a GCF, a greatest common factor of 2. So I'm first going to start my factoring process by factoring out the GCF. That would be 2 times x squared minus 6x minus 16. And then if that can continue to factor further, we can keep going. I could go ahead and factor the denominator right now if I wanted to, or I can leave it for the next step. Either one is okay. That numerator would continue factoring. It would become 2 times x minus 8 times x plus 2. And then we factored the denominator. X squared minus 14x plus 48 would factor into x minus 6 times x minus 8. And now looking across this, I do see a common factor of x minus 8. So that would reduce out to leave me with the rational expression, which is 2 times x plus 2 over x minus 6. Now I can leave it this way because it's not going to factor any more and simplify any further. Or I can multiply the numerator out to be 2x plus 4 over x minus 6. Either one is fine because those are equivalent expressions. Next, we want to multiply rational expressions. So when we're multiplying fractions like we traditionally did, we would multiply straight across. So we're going to multiply straight across and then reduce if possible. In this one, this would multiply to be 4 times 5 over 15 times 8. That'd be 20 over 120. And that does reduce. It reduces to 1 over 6. All right, so we want to extend those same ideas. We first want to put these in factored form. So if it's not already in factored form, it's helpful to put it into factored form. That would make this n plus 6 over 5 times n minus 7 multiplied, so times, and then that numerator also factors into 5 times n minus 2, and the denominator has a GCF of 9, so that would be 9n actually, times n plus 6. As I look across this, I can multiply straight across. Because this is all factored, n plus 6 times 5 times n minus 2, I could write as 5 times n plus 6 times n minus 2 over, and then we have 5 times n minus 7 times 9n times 5, or n plus 6. And it doesn't really matter what order you're writing this because they're all multiplied. And in a minute, I'm going to show us kind of a shorter hand version of this anyway. Because we're looking for common factors. So what I would notice is there's a common factor of 5 in the numerator and denominator. There's a common factor of n plus 6 in the numerator and denominator. So what we're left with is n minus 2 over 9n times n minus 7. There's no other common factor to reduce, so that's the simplified version. Now you can go ahead and find those common factors before you just multiply straight across. So I could have noticed that there's a common factor of 5 in the numerators, and there's a common factor of n plus 6 in the numerators. So when I multiply straight across, we just have n minus 2 on top, and on bottom, n minus 7 times 9n. And that gives me the same expression that we ended up with. All right, to divide rational expressions, we treat it a lot like multiplication. But that's because dividing by a fraction is the same thing as multiplying by the reciprocal. Now in elementary school, it was often taught as keep, change, flip. So we would keep that first fraction, 2/7, change the operation to multiplication, and flip the second fraction to 21 over 8. That's because we have, instead of dividing by 8 over 21, we're multiplying by the reciprocal 21 over 8. And then you would multiply straight across. You could also simplify some as you're working this. So 2 over 8 would reduce to 1/4. And 21 over 7 would reduce to 3 over 1. So if you multiply straight across, you get 1 times 3. And across 1 times 4 is 4. So this would reduce down to 3/4. So if we keep those same ideas and extend this to a rational expression, we still want to put it in factored form. But so we have 8 over a plus 7. We're dividing by 10 over a squared minus 2a minus 63. Now I could write that in factored form and do a plus 2, or a plus 7, I mean, times a minus 9. And when we write this as multiplying by the reciprocal, we would have 8 over a plus 7 times the reciprocal, which would be a plus 7 times a minus 9 over 10. So the a plus 7s would reduce and make this 8 times a minus 9 over 10. Now that can reduce as well, so I'm going to bring this down just a little bit and look at 8 times a minus 9 over 10. The reason this would reduce is because we have these constant factors. We have a constant factor of 8 and a constant factor of 10. That can reduce. 8 over 10 has a common factor of 2, so think that as 2 times 4 and 2 times 5. The 2's would divide out and leave me with 4 over 5 here. So this rational expression would simplify to 4 times a minus 9 over 5. And if you wanted to distribute that numerator, you could. Lastly, we want to add and subtract rational expressions. So we think about, how did we do this when we were in elementary school learning about fractions? We would get a common denominator and then create some equivalent fractions using that common denominator, and then add or subtract the numerators. So if I have 3/8 plus 1/10 and we get a common denominator here would be 40. So what we're doing is trying to scale up the fraction to have a common denominator, and we do that by multiplying the numerator and denominator by a value to get me that common denominator. That common denominator being 40 would make this first fraction scale up by a factor of 5 here. All right, and we're going to add 1/10. All right, so 1/10 needs to also get a common denominator, and that would be scaled up by a factor of 4. So we've created equivalent fractions. Our equivalent fractions here are 15 over 40 plus 4 over 40. Now that we have a common denominator, we can add the fractions together to get 19/40. So we wanted that common denominator, then we could do the operation of addition or subtraction. So if I look at a rational expression like this one, 2x over x plus 1 plus 5 over x plus 3, our common denominator in this case is a factor of x plus 1 and x plus 3. So we're going to create equivalent fractions that just has a common denominator now. So let's look at what we have. 2x over x plus 1. To get that common denominator, I would need to multiply the fraction by x plus 3 in the numerator and denominator. So think about, if we were working backwards, those would have reduced out to leave me with just the 2x over x plus 1. But we're trying to get that common denominator so that we can combine these. So the next one is 5 over x plus 3. And it is going to need to be multiplied by x plus 1. All right, so our equivalent fractions we can now add together. All right, I'm just going to go ahead and multiply the numerator to distribute and get 2x squared plus 6x. And there's really no need to multiply out the denominator. You can, but we don't really need to. Writing it in factored form is fine. There's a reason why I multiplied the numerator, and that's because we're trying to add the numerators together. So 5x plus 5 in the second fraction. And we have a common denominator of x plus 1 times x plus 3. Since both of those fractions have the same denominator, we can add the numerators together, and this would end up giving me 2x squared plus 11x plus 5 over our denominator x plus 1 times x plus 3. We do want to check to see if these things can simplify. So maybe that is our final answer. Maybe that's as simplified as it's going to get, but we would need to double check. And we check to see if there's a common factor to simplify further. So let's look for a common factor. There's a little bit of a delay, sorry about that. But so 2x squared plus 11x plus 5, that might be able to factor, but it also might not. So we just need to work with that to see if it can. All right, so 2x squared is coming from this factorization of 2x times x. The 5 is going to be 1 times 5, and that does factor into 2x plus 1 times x plus 5. So since the numerator does factor, we would look to see, do we get a common factor? And we don't, because the factor 2x plus 1 is not identical to x plus 1. So that fraction cannot reduce further, which means either form is okay. You could leave it in factored form, but we don't have to. We could also leave it in the distributed form, 2x squared plus 11x plus 5 over x plus 1 times x plus 3. All right, so all of the fractions can be done the same way as regular fractions, whether we are adding, subtracting, multiplying, or dividing. The one thing I do want to remind people about, let me go back to addition, is subtraction. So when we're subtracting, you want to be careful with that subtraction because you're subtracting the entire numerator. If I look at this one again, so let me bring this to another slide here. Okay, pretend that this was actually subtraction. All right, so if we had changed the operation to subtracting these, you want to be careful because you're not subtracting just 5x, you're subtracting the entire fraction over here. And so what I recommend to students is that we do 2x squared plus 6x minus 5x minus 5. You're distributing the subtraction over this way, over that denominator, which would have been x plus 1, x plus 3. So in that case, our simplified answer would have been 2x squared plus x minus 5 over x plus 1 times x plus 3. So just be careful when it comes to subtraction because you do need to subtract the entire fraction.